Hello everyone, my name is Sahithi. I am pursuing BSc Computer second year at Spaces Degree College. Today I am going to explain about TS diagram. Is nothing but temperature entropy diagram. It is a graph which is drawn between temperature along y-axis, entropy along x-axis, which represents the working of a reversible heat engine, and it is called temperature entropy diagram or TS diagram. Here we have to explain the working of Carnot cycle and efficiency by using temperature and entropy. For this, consider a Carnot cycle under PV diagram. This is the PV diagram. In isothermal expansion AB, the temperature remains constant at T1 and absorbed heat energy from source is Q1. In adiabatic expansion BC, the temperature falls from T1 to T2 and heat energy remains constant. In isothermal compression CD, the temperature remains constant at T2 and rejected heat energy to the sink is minus Q2. In adiabatic compression DA, the temperature rises from T2 to T1 and heat energy remains constant. By using these changes, we have to measure the work done. W equals to Q1 minus Q2 and efficiency is 1 minus T2 by T1. When the heat energy is working under temperature and entropy, then we can observe TS diagram as follows. Here is the TS diagram. Here T1 equals to AE, T2 equals to DE. So S2 minus S1 equals to EF is BCAB. We know that the entropy changes linearly in isothermal process and remains constant in adiabatic process. Using these changes, we have to explain the following 4 changes in Carnot cycle. In isothermal expansion AB, the temperature is constant at T1. The entropy of work done substance increases from S1 minus S2. Here, heat absorbed from the source Q1 equals to T1 into S2 minus S1. Using second law of thermodynamics, W1 is equals to Q1 equals to AE into AB. In adiabatic expansion BC, there is no change in entropy, but temperature falls from T1 to T2. In isothermal compression CD, constant temperature at T2 and entropy decreases from S2 to S1. Then Q2 heat energy is rejected to the sink. Q2 equals to T2 into S2 minus S1 equals to BC into CD. So minus Q2 equals to area of CDEF. Finally, in adiabatic compression DA, the entropy remains constant but temperature rises from T2 to T1. So by combination of these 4 changes, TS diagram indicated rectangle shape ABCD. The area of cycle of TS diagram gives the available energy which is useful for work in a reversible process. From the above equations, the available energy for each cycle converted into useful work is equals to Q1 minus Q2. Available energy W equals to area of ABEF minus area of CDEF equals to area of ABCD. Let us find out the efficiency for TS diagram. Now, efficiency can be defined as the ratio of amount of work done to amount of heat energy absorbed by the heat engine. So, efficiency equals to work done by Q1 equals to Q1 minus Q2 by Q1. Efficiency equals to 1 minus Q2 by Q1. Then efficiency equals to area of ABCD by area of ABEF equals to area of AB into AD by AB into EF. Efficiency equals to AB by EF. Then T1 minus T2 by T1. Then finally, efficiency equals to 1 minus T2 by T1. This is the expression for Carnot reversible heat engine using TS diagram. Hence, the efficiency can be depends only on temperature T1 and T2, but it doesn't depends on working substance. Uses of TS diagram. By using TS diagram, the concept is used in meteorology. This is used in prediction of defects in the performance of heat engine. It is used to find out the work value of the fuel which is used to run the heat engine. It is used to find out the efficiency of heat engine. It is used to calculate available energy for each cycle to heat engine, which is useful to convert work done. Hope you all understood. Thank you all.